So once again, greetings from MIDAS India. So my name is Pratap Jadhav, and I'm working in MIDAS Research and Development India as a structure engineer, senior structure engineer, uh, looking into the Middle East, Africa, and the India region. So thank you for attending the today's session. And so the today's topic is integration of MIDAS Civil Linux with Excel VBA and the MIDAS Connector. Okay. So if we have any questions during this session, feel free to mention it into the chat box and we will definitely try to answer them at the end of the session. So moving on. So basically nowadays the structural engineers are using various softwares for their different purposes. So maybe like for the analyzing part, they may have the different analysis tools, and whereas for the drafting, they may have some CAD tools. So whereas if you talk about the analysis part alone, so we do have again the various functionalities either by Excels or by that particular software tools or by even the other way as well. So such type of actually the organizations they actually uses the various tools nowadays and yeah. So based on the availability of that particular functions in that software, we can work on that. But what if there is actually the repetition of the same things again and again, and that may take your time and as well as of course it's very difficult. So that's why so this such type of process we have actually independently actually made and we have tried to made automation into the MIDAS Civil Linux. So this change required something to be actually, reworked by using the other uh, tools which can be integrated with our current version of softwares. So summing up, basically there are three main problems where the engineers need the attention and they need actually the help to in that particular situations. So first is a lack of interoperability between the software solutions. So one software they are using for let's say the analysis purpose, another software they are using for design, third software they are using for the drafting of the drawings and all. So what if we integrate all these softwares together? Second is regarding the report generation. So of course, when you are actually submitting the report, that requires a quite actually the the time as well as the efforts. In case if you are actually doing the same work again, let's say that particular report need to be updated with the modifications mentioned from our that let's say the proof checkers. So definitely it is a repetitive task. Okay, and the whole process we need to do it again, analyzing the structure same in the software, getting the results, and then do the report. So such type of this particular repetition of the task and all. So we have actually introduced an API in the process of how we can quickly solve these particular problems. So one of them, this integration, we already actually discussed in our earlier session. That is a MIDAS Civil NX plugins, okay, where we can do a quickest modeling of the any components. Now we are talking about the second, we can say the functionality that is actually the Excel VBA integration, and plus in the Excel we are also coming up with the MIDAS connector. So how these two functions will be helpful for us, that we'll discuss in our upcoming slides. Okay. So this is the agenda for the today's session. So first we will be discuss about the Excel VBA, because all the civil engineers or the bridge engineers they are not most aware about the Excel VBA, but yes, we can take the help of this particular VBA tool for our analysis as well as for the design purpose. What exactly the JSON will do when we integrate the MIDAS Civil Linux with the VBA? What are the automations are available in the current version of MIDAS Civil Linux? But yes, we can do it manually as per our interest and the choice. We'll see some examples here. So I will be actually taking a simple beam, and also I will showcase one video for the PSC composite diagram which we have prepared from our side. Then coming to the next part of this particular session is the MIDAS connector. So there is a add-in which is actually available when you are working with the Excels, and that will help you to generate the reports. Okay, so that will definitely reduce your repetition of the task. So that for that we will see the example and then the summary. So talking about this particular VBA, so VBA is basically an programming language, and it's actually primarily used for the macro programming in the applications within a Microsoft suite. Microsoft Office suite we can say like Excel, Words, PowerPoint, Access, and so on. So with VBA, users can automate the task and add the custom functionalities to these applications. So whatever the applications you are using, let's talk about the MIDAS Civil Linux. So here are a few of the key features and the purposes of VBA. So first is the programming language. So this allows user to write the any code using the conditions, loops, variables, functions, objects, and so on. Secondly, automations. So this enables the automation of the repetition of the task. Third one is the user-defined functions and macros. So here the users can create the customized functions and macros so that that can be reflect your the software linking as well. Event handling. So here it allows user to handle the occurring events in applications. For example, I can actually specify some parameter, and when I click on the button, I can actually generate the click button there, and it will get reflected in the software which we are linked with that one. Third is the macro reading. We can record the action of everyday task so that we can generate a complete VBA code as well. And the last one is the access to database programming. So it also provides the functionality to interact with the databases available in the other programs. Okay, so we'll discuss in details in the further slides. So here the user needs to assistance from the external libraries to handle the JSON data in VBA. So we have actually the Microsoft Excel, we have the MIDAS Civil Linux, and to link this to actually the two different applications, we are actually using the JSON. Okay, so through this particular JSON, we are actually transferring the data from Excel to MIDAS Civil Linux and from MIDAS Civil Linux to Excel as well. So VBA itself does not have the built-in functions or libraries for processing of the JSON, but we are actually providing some JSON library, okay, so that it will be easy for to link that with the softwares. So we'll actually talk about this particular procedure. So first step here is about the installation of the VBA JSON library. So the JSON VBA library provides functions for parsing and generating the JSON data. Okay, so that we'll discuss in detail. I'll show you. Second is the adding library to the VBA project. Okay, so once you open the VBA, okay, so there we'll actually add that particular library, JSON library. Third is the VBA reference. So we'll again add the Microsoft scripting runtime function to work with the VBA along with our server. Fourth is the parsing JSON data. So this is required for creating the JSON data in the VBA. And finally, the connect API server. So here we require two parameters, base URL and MIDAS API key. So that you can get it possible from the MIDAS Civil NX software. You just need to open any new file, and that particular MIDAS Civil NX key, that, or we can say MAPI key, that can be added in the Excel so that we can get it linked. Okay. So what are these particular automations in MIDAS Civil NX can be possible? There are several application areas. I have listed few of them. Creating the load combinations. Let's say the MIDAS Civil NX provides some standard database of the country codes. But what if there is some countries are not available in the list? So definitely we can create that one by a user-defined library through the Excel VBA. Next is a curved RSI model generation. Now currently the Civil NX or the MIDAS Civil RSI wizards generate the straight alignment for the RSI analysis or ray track analysis. What if my alignment is in curvature? So definitely the created geometry from that particular RSI wizard can be updated to the curve using this particular VBA tools. Third is the built-up section generations. Again, we are taking the help of section property calculator tool to generate any type of cross section. But what if I want to standardize it? So I can have the standard VBA code which is written for any type of let's say channel front to front, and I want to actually create for that. So I can create the library. I just specify the dimensions, and based on that, at that section will be generated the software. Linking the analysis forces with the design sheets. So that is again the additional benefit here, that using the MIDAS connector, we can link the analysis results with that particular your in-house design reports as well. generation of the tendon profile coordinates. So that is again somehow like though there is actually tendon template available in the software, but let's say as per the analysis and as per the bending moment diagram due to the applied load, if I want to calculate and optimize the tendon coordinates, so that can be done using this particular VBA tool. Section property optimization. I have a one beam and we are specifying for the given load what will be the section depth for achieving that limiting value of the stress. So that iteration will be done from this particular VBA tool that we will discuss in our today's session during the demonstration. So there are several as well. So that is how till now, as for again like just for a test cases, we have created the VBA template for the simple beam analysis and as well as for the we can say the section optimization. Second, we have created for the RSI analysis that we can actually convert the alignment to the curve or even any type of curve it is, either it's a circular or it is a transition curve and anything. And then the third one is regarding the pre-stressed composite beam girder. So just like the wizard, but again, wizard has its own actually the limitation. Okay, but that can be reflected and that can be actually withdrawn by using this particular Excel VBA. So you can do any type of actually the work or the task by using the Excel VBA. So just have a short video about this. So this is actually for the pre-stressed composite eye girder bridge. And first we need to connect the API, okay, through this particular MIDAS API key and the base URL. That the MIDAS API key can be actually specified here. It changes file to file. So after editing all these particular parameters, so I just wanted to actually show this in detail, how this particular Excel looks like. Okay, so just for actually the understanding purpose, I'm just opening this particular complete Excel which is prepared for the pre-stress composite eye girder bridge. As you can see, we have this particular two options available: create model and analysis. Make sure that this Excel need to be connected to the MIDAS Civil Linux model through this particular key. Okay, so that will connect to our server, MIDAS server. Then we have this particular the guide diagram. Referring to this guide diagram, we can specify what are the location of the diaphragms, what is the location of the girders in the transverse directions, total length, everything can be mentioned here. Then in detail, what are the tapering locations? Okay, what is the center line distance? What is the girder face from the center of the bearing? Everything can be specified here. The space section properties for the end as well as for the mid sections. So again, the details regarding again at the diaphragm, and after that there is a extension of the girder that's specified. The cross beam locations at the intermediate location where the two girders are connecting. If there is any again the expansion joint that can be added here. The material properties can be listed here. What are the different loads? Steel material, pre-stressing data. The tendon profile can also be updated here, specifying again the jacking force. Then the different loads which are coming during the construction stages, the position of the vehicles. So again the specific locations that can be actually mentioned here. Construction stage analysis, the location of the crash barrier and corresponding to that the wind load application and the load combination. Okay, so all these particular parameters can be customized within this particular single Excel, and then in the next sheet we can take the results in terms of images as well as in terms of the table from that analyzed model. So there is option for analyzing the model in this particular Excel itself. So let's move back to this particular video. So if you check here, when we click on this particular create model, so it starts generating the geometry, and you can see the complete geometry along with all the units and with the alignment as let's say the skew, it's got generated. Okay. So once we actually generated this particular model, then you can perform the analysis within a software, and then this will okay. So these are again the construction stages. For each and every construction stage, how the members are activating and the loads are activating. Then we'll perform the analysis. Once the analysis is completed, okay, so then we can see the output that can be actually get linked in the MIDAS through MIDAS Civil Linux to the Excel. So nowadays we are also checking this particular progress of the analysis as well. So here we need to just click on the get results table and get the results images, and so that's how the results can be linked here. This is in the tabular form, reactions, and similarly the forces, any other results can be taken here. And this is for the diagrams. Yeah, so the stresses or bending moments, everything can be actually taken one by one in this particular customizer templates. So that's about this particular Excel VBA. Right. Now let's go through one example of creating the simple beam with a rectangular section using the VBA. So considering the characteristics of VBA, we will use the Excel sheet for this particular example. So we'll be discussing the optimization of the single span beam, and we'll try to limit this particular bottom stress. So the criteria will be made by increasing the depth for every analysis iteration, and the corresponding forces, the corresponding stresses with that particular depth can be checked in the VBA itself. So here we are limiting the bottom stress of 10 MPa. Let me actually take you to that particular thing. So before that, the procedure is, so here, so when you are working on this particular VBA, there are certain actually the process which we need to follow. First is setting up the environment. Okay. Second, so environment means we are actually activating the macros and the VBA. That is a developer tab, we can say, in the Microsoft Excel. Understanding the JSON manual. MIDAS provides the standard format for the JSON manual, how it will work. So for one example of creating the nodes, actually we can start again from that. Defining the sections, updating the existing section, extracting the bottom stresses, analyze the model without any analysis button into the software, and then use the optimization of the stresses sections for that particular stress. So that's how actually this is the complete procedure. And taking to this particular manual. Okay, so here we have the manual for the API. Okay, in that you may find even the examples as well. So here in this particular manual, for each and every parameter, we have a particular, let's say if you are talking about the creating the node. Okay, so here for creating the node, this is the URL, input URL. Now the person should have a basic idea about the VBA, and from that he can coordinate with this particular JSON format. Okay, so from this particular JSON format, okay, what are these particular parameters suggest, and after that then we can actually see, okay, for the nodes how we can actually specify the coordinates. Okay, so that is how actually we can compare with this one. Right. Now let me actually take you to the another things, like we have actually the VBA examples available in our portal. So just I show you. Yeah. So this one is the example for the Excel VBA. Sorry. Yeah. So here, if you go to the MIDAS support, and here we have actually the examples. Okay, examples as well as the manuals. So here there is Excel connector, plugins, Civil NX, and the Grasshopper Civil NX JSON manual and the examples. So in these examples, you may find the VBA, Python, and the for the other languages as well. VBA. So here actually the complete procedure has been given, the one which we have discussed till in that particular till now. Okay, so first is whenever you are working with this particular Excels, okay, so you need to actually check first. We can go to the and the automate options are checked. Visual Basic, I'll close this. Okay. Then we need to have this particular converter. Okay, so JSON converter, this can be actually taken, okay, from our Git website. So that is, again, I just show you. So that is actually already explained here. Like yeah. So first stage is installing this particular JSON library. For that, GitHub website is given, and from where we can download this particular GitHub website, so that that particular file which will be required for uh, connecting our VBA with the JSON. Then yeah, then we will actually open the VBA project, and so from here I will explain this particular procedure here. So I'll go to the Excel and the VBA. Let's close this. Okay, so here in this particular Excel, we'll go to the Visual Basic, and in this particular Visual Basic, so we will open the one module. So first I'll import it, this particular JSON file. So this is our module, and you can add the additional module as well. Then we will run the sorry. First we will actually add the Microsoft scripting runtime file, okay, so that it will open our code, right? So you may add the additional. So we can go to the insert and we can add the further modules here as well. Okay. So to start your work. Next step, now you need to create first the Excel file for which you are interested to do your working. So let's say we are talking here about the definite creating the, let's say, some number of nodes, and then we can further discuss about the how we can change the section size, how we can do the optimization, how we can perform the analysis. So for that, uh, there is actually a one customized the example is given for generating this particular Excel VBA. So those who are actually new to the VBA, they can go through this particular example. Okay. So I already created this particular example in a stepwise procedure. So let me that show you here. Okay. So the complete, let's say, the main actually the idea here is creating that particular beam and then optimizing it. So first is regarding the initialization of VBA. Initialization is nothing but we are customizing our, let's say, the data in which we are specifying some integers, we are specifying some doubles, that is the data in the digits, sorry, the decimals, strings. So we are specifying some data here, and some dictionaries. So dictionaries, we can say it is a collection of data. So just I already created this pattern. So this is actually the initializer data. So I can just copy it. Okay. So it just we have only the definition, initialization. There's no any data defined here. So I will open this here, and parallelly I will open the MIDAS CVLNX software as well, because now I want to actually see the reflection of the VBA with that particular MIDAS CVLNX. So I open this particular model of the CVLNX. Okay. And here we have already prepared a simple beam definitions. So first is when I open the Civil NX software, from there I will go to the application API setting, and here I just refresh, I'll connect it, and then I'll copy this particular MIDAS API key that I will put sorry, here I'll put that particular API key here, so that my this particular VBA file will be get connected with the MIDAS CVLNX. Now the data required is, so section one section I'm creating, that is the ID 1. I'm limiting my stress to 10 MPa till where the software will do the iterations. Dimensions are 0.3 meter in width and 0.1 meter in depth. Depth increments, that is for every iteration it will try for 0.05 meter. Okay, so it will start with 0.1, so 0.15, then 0.2, then 0.25, like that. Then element numbers, that is at the mid span. So I'm taking actually the 10 meter length of the beam. So we can have the let's say the center, that is the fifth element, and the starting of that particular element, that is part I. Okay, that we already know. Now this, if you go to this particular now the VBA, let me actually go to this software and this one. Okay, so I'll close it, and I'll open the VBA as well parallelly. Okay. Okay, so this is VBA and this is the civil. I'm just putting it side by side, so that whatever actually the changes we are making here, that can be seen parallelly. Right. So here, now we will start with these particular definitions. So first is regarding this particular function. So initialization of the data. So that actually we already added here. That is my first data here. So I will that add here, and these are actually the dimensions, and some strings we are going to define, some integers, doubles. So that is actually our first part, that is the initialization. Second part is creating the specifying the web request. So in this web request, I'm specifying that, okay, so there is actually function for web request, and we are going to connect with the MIDAS API key and the base URL. So this web request and the MIDAS API key, these are actually variable, and this is actually constant. So URL we can keep constant, but as it is a variable, so we can specify it as a variant. And where we need to actually copy it. So this is a base URL that is in cell number D6. So if you open this particular Excel, so already this data is in D6, and our MIDAS API key is in D7. Okay, so that's what actually we'll copy it and we'll paste here. Now so that's actually done. The next is regarding the creating the nodes. Okay, now for creating the nodes, now I'll actually compare this with the JSON manual. So let's go to the JSON manual here. So in this API manual, sorry, okay, here I already actually opened it. So yeah, so here in this particular API manual, if we actually go with this particular definition of the node, so let's say I'll go to the back, that is in the JSON manual, and in this particular JSON manual, so for creating the node, now if you check parallelly, like for creating the node, here we have actually the option that is the to create the node, and sets are nothing but we are actually making some functions. So there are different loops which we are creating. Okay, so let's say the set d main 1, then set d sub 1 sub 2, these are actually the subsets. Okay, in that we are specifying the variable that is 0 to 10. So I'm going to create the 10 nodes. Okay, and the first node will be start with, so there will be first node will be variable that is 0 to start with 0 to and it up to 10, whereas y and z are 0 because it's a straight line without any changing in the y and z direction. That is what we are mentioning here. So from that, the post is nothing but we are creating it. Okay, either to create it or to we can say to copy it, we are specifying this particular post command. That is what actually it's an action. So and these are actually the coordinates which you have mentioned here. So actually we are taking the help of this particular API or the JSON manual, and we are trying to link this with the VBA. So from that, so if I actually specify this parameter, so my first 11 nodes will be created. Okay, let me just delete this module. Okay, let me just remove this whole thing so that I will compile it again. Okay. Yes. Yeah. So this we actually first started with the initialization. Then next is the web request. Third is regarding the nodes. So for this node, make sure that our Excel has already actually connected with this particular MIDAS API key. So I'll copy it again and I'll try to paste it faithfully. And just I will try to then run this particular code. Okay, I think okay, let me just move further. So here, meanwhile, I just complete this particular code at least by explaining this one. So here mainly we have actually specified this particular code till the definition of the node. Now next is regarding the section. Okay, so for section, if I actually check this, so we have actually the section definition. Now again, if I go to the our JSON manual, so you can find here. Let's say for the, if I again go back to the JSON manual, and if I go for creating the section, so it's, let's say, the properties, and in properties we have the section properties. So in that I am defining the, let's say, the DB user. So in this DB user, so in the DB user, here actually we can see, let's say we are defining the section property for a solid rectangle. Okay, now this is actually the standard format which I have just actually tried to actually keep this in this particular for VBA. Okay, so in this we need to actually make sure we have actually the number of sets. So first set is, let's say, the whole, actually you can see the number of this particular curly brackets. So basically these are the different actually the loops. Okay, so first loop is for assigning the whole cross section. Next is for defining the let's say this particular first assigning that section. 19 is nothing but your section ID. Okay, so what is your section ID? That can be specified here. Then we have the let's say we can have the what type of cross section it is. So that can be defined. Then we have again the further in a one particular section database. So if you check the cross section properties, let's say if I go to the properties, section properties, add, here you can find the n number of section properties here. And suppose if I'm defining the solid rectangle and user, so either we are selecting the shape, we are specifying the user define option, then name, section ID, dimensions, offsets, uh, these options as per again the requirement, and then the data, right? So that's how actually this all the parameters are actually mentioned in this particular sequence, right? So that's what actually this loop has been created for this. So I just specified this one as well for defining this particular function. I think okay, I need to actually save this particular file. That is why actually it's not running. Model 1. So I'll copy this data and then I'll go to the VBA. So we'll try to run it. So this is for creating the section. Okay, let me actually debug that one later on. Further, so next is regarding the updating the section. Okay. So here updating the section means we have specified some dimensions here. So in our Excel, we might have actually specified the section depth of 0.1 and width of 0.3. Now we need to change this parameter. Okay, like let's say instead of 0.1, I need 0.2. So just by changing this particular updating section, I can give the loop variable. Okay, so this loop variable will work like in such a way that okay, what are the dimensions we have specified in this 14D and 11D? So 11, 12, 13, and 14. That if you can check here, 11 that is a section ID, 12 is your width, 13 is the depth, and then variable means for every iteration we are changing this particular depth. So that we can specify under this particular 11 to 14 number of cells in the D format. So that actually we can specify here. So that is our next we can say loop. Okay. Will I just cross check with this one? Okay. Then next is regarding just completing this explanation first. So then we have the checking the updating the section code. So here, let's say instead of that particular 0.1, I want to update that with the let's say two loop variable. So for every iteration, I'm keeping 0.05 of my iteration, right? For every iteration, we are changing that one. So what if you want to change for further? So that can be done from this particular loop variable and call this update section with the loop variable and then end of this particular function. So that we can specify here. So that is actually optional. Then we have the analyzing the model. So whatever the geometry we have created, if you want to run the analysis for that, so that can be done in the further code. Okay, that's the analysis part. And then the basic, like whatever the stresses which is developing. So to call that particular stress, okay. So again, if I go to the JSON, so here to see the results for that, so here there is actually option for checking this particular result and to get the results in tabular form. So the analysis results, the analysis results either in tabular form. So yeah, analysis results table. Here, suppose I'm taking the stresses. So we can go to the beam stress. These are the beam stress option. And in this particular beam stress, we have the option for post table. Okay, and in that particular post table, so if you are checking for, let's say, beam stresses, so this is actually the complete actually the code for that. So here actually we are calling again, these are the different sets, okay, for the different dictionary we can say. And here 16 and 18. Now if we check our Excel, so our 16 table is for that 11 number, and 18 is nothing but what is the end of that particular element. Okay, so fifth element and ith part, so that we are actually recalling, and from that up to 3 decimal, and which are the force component, which component you are interested, let's say the beam stress table with bottom stress CB4, okay, which load case, which is UDL. So this can be actually called here, and we can actually generate this particular stresses here. So let me just paste it. So this is actually the calling this particular beam stresses. And further, now when I want to actually check this section optimization. So section optimization means we have actually this name can be anything. Okay, so here beam optimization we are doing, limiting criteria is in 9D. So this 9D is our 10 MPa. Okay, so we are limiting to that value, and the total we are performing 10 iterations. For every iterations we are doing this one, and for each iteration it will check the beam stresses and make sure that the stress bottom which we are getting, so we are calling this particular function again, and every time it will check for what is the stress limit which is provided in this particular cell 9D, else it will debug. So it will not iterate for all 10 iterations, but it will iterate till where the stress is within that particular permissible or the limiting value. So that is how this particular function will work. Okay, now let me actually reopen this one. Probably actually I might have actually created something wrong. Okay, so I'll just open this particular first Excel for the optimization. Okay, I'll enable it. Then we'll open the civil annex. Okay. So in this civil annex, I'm starting with the okay. So just open the new file and save the file. So I'll save this file and just give the name as, let's say, 1. Now, so in the Excel VBA, I'll open the developer tab and the Visual Basic. Okay, in this, okay, first we'll install this particular library, that is import, and we'll open this particular JSON library under the module. Yeah, then so after okay, then we'll go to the file and we'll actually define this particular tool menu. So that is for the tools and references, Microsoft scripting runtime. Okay, for that, then I go to the Excel and whatever actually the MIDAS API setting, so I just connect it with the MIDAS server, copy and close, and we'll go to the JSON file, and here we'll paste this particular mapping. and enter. Okay, then we'll go to the now the Visual Basic VBA and we'll just copy the code. So probably we'll actually first start with the definition of this particular initial settings. Okay. The next is for the web request. So already we have specified this particular data. So that is a web request. Then we'll first try for the definition of the the coordinates for this particular node. So here coordinates will be defined and this will user defined module. Okay, I think I'm facing some difficulty in my VBA. Okay, so probably so when you are actually defining this particular whole code, so that can be actually integrated. Maybe I think we'll share you some short video for that, how actually it will work. So that's about actually the let me just try with one file. Okay, let me actually try connecting this file so that I can actually explain this one. Let's say if I find two, it's optimized. Okay, this is actually working here. Probably my actually I think the VBA for this particular file is not exactly working. Okay, so here basically I think for this it's not working, right? Let's say if I want to actually change any parameters, so I previous actually so let's say 0 0.5 by 0 0.3, but let's say instead of 0 0.5 by 0 0.3, I want to make that particular section into a 0 0.5 by 0 0.5. Okay, so this such actually type of actually the reflections can be actually done easily through this particular things. Okay. Maybe just actually this VBA part I'll actually try to modify in our my other video, and I will share that video along with this one. Okay, so about our next part, there is a MIDAS connector. So MIDAS connector actually it's again a newly launched options available in the MIDAS Excel, Microsoft Excel add-ins to make the communication between the Excel and the MIDAS Civil Linux. Okay, so we can call the results such as the table in terms of tables or in terms of the images as well. So in the currently we are actually able to actually import the interpretation of results through the tables into the Excel as well as the images into the Excel, and even we can link the Excel with the MIDAS Civil Linux as well. So for again for that, if I again show you the one Excel, let's say I'll open the newly built Excel. So users need to have actually the add-in option in, and in that add-in we can actually call for MIDAS connector. Okay, So that is actually the MIDAS connector option that we need to add. So I already added here, and here then we need to have the connection between these particular files. Now for connecting it, so we'll go to the setting, okay, and here we need to actually add the API key, okay, that is for this particular model. Let's say this is already analyzer file, right? For this particular analyzer file, let's say it's a simple beam which we have created earlier, and I need to actually connect the API key with this, so that I will add here. So I'll check with this. So this is valid, and then I'll click on apply. So it's not that got connected. Okay, now if I go to the model, okay, suppose I want to actually take some images. So I'll click on dynamic report image, and I'll give the image, let's say model view 3D. Okay, click on OK. So as we know that we have the option for this, let's say I'll just delete this, and we have the model view 3D. This image I want to take into the Excel. So simply here you can, suppose here you can click and you can specify that particular location where you want to insert that image. Select it from the selection option, and here okay, we are talking about the table here, but start first is the image. So here I will link with the B2 and saved image which you already done, and the name is, it will show here. So just folder will be default and click add to the folder, so that image will be got updated here, and then click on again go to the software, see the results, let's say the reactions. So it's actually a simple thing that the vertical reaction will be coming for this particular support reaction. Okay, so this image I can actually take into the, again the form, that is a reaction. Okay, this is the reaction, again that is saved. If I want in tabular form, so results table reaction for this load case, click on OK. So this table also I can get in the dynamic report. So I'm interested only for the vertical reaction component, so I can get that one as well. Okay, so let's say I have taken only 3 cases here. Okay, so now I'll go here, and now what I'll do, so here for this particular report we have first, let's say the results table. In results table we have the B2 selection and reaction table, right? So that reaction table we can select in the default group, add it. Then so I will click on the update that particular table here, and that will be updated in this particular table here. Next is suppose if I go to the image, so here in this particular image I can click on the update, and it will got connected with this particular image format as well. Okay, so that's about this particular image format. But let's say I want to actually take the that particular results table. Okay, so for results table I'll go to the results table, and this table, okay, let's say I'll go to the next sheet, and here I want to actually paste that one. So here I'll link with this particular B2. Okay, and here we'll select it, that is a reaction table default, and add to this particular table. So it in sheet T, I don't want this sheet 1, let's say, so only sheet 2, and then add it. Okay, so here make sure that you already actually taken that particular table into the report. So if you check this particular table, okay, so this table we can add in this particular things as well. There is actually option like we can actually use with the query as well. So query means suppose again if I go to this particular table form, and instead of calling this, let's say I change this particular coordinate here from here, and instead of selection I'll go to the query. So there is actually standard format for that. So again we'll add this to the table and then import it. So likewise we can take this particular results and table into this particular query dialog box. So there are certain actually the options where we can update all this particular table. For example, let's say if I go to the model, and in this model, okay, suppose I want to change this particular depth. Okay, so I'll go to the works, and let's say in this particular section property I want to change the depth to, let's say, 1 meter. So the reaction will change, right? So I'll perform the analysis, and then we'll go to the results, reactions due to the UDL. Okay, that is, I think, UDL value you can change, otherwise we'll see the deformation better then. So the displacement UDL in the vertical direction and the values. This is my deformation. Okay. Suppose if I take this in the table deformation in the report form using this particular dynamic report image. Okay. So that is got saved here in our report tab, and this deformation now I can link here. So I'll go to the Excel sheet here, and we'll go to the result image. Let's say I will remove this. Okay. Suppose for this particular B2, okay. So whatever the saved image is there, that I want to add it, and then update it. Okay. So now you no need to actually work on like, okay, right now actually I'm getting this particular value, but let's say by software, if I want to actually change this particular depth, and the same thing will be need to be actually reflected in the Excel as well. So again, I'll go to the material properties, and suppose I'll take the, let's say, the highest grade here. Because of this, the deflection will definitely will change, and plus let's say the section property got changed to, let's say, 0.1. Okay, now and then I'll run the analysis again. Now the deformation of that particular structure will change. So if I check first that particular displacement, how much we are getting. Okay, so we are getting 1.194 meter deflection, but you no need to do anything here. Just select it and just click on all image and update. So automatically that image will get changed. So this is actually the extension of the MIDAS Civil Linux, Civil towards the Civil Linux for the updated results based on the input parameter changes in the Civil Linux. So we can work in the both the ways. Either we can work in the that taking that images and tables, or we can go with this particular, let's say, the tabular form. Tabular forms, and in this particular tabular forms, I can link, let's say, some locations. Okay, and that's location, instead of selection I'll go with the query. Okay, so suppose I want the reactions, I will add it, and then for that we can update this particular tables as well. So likewise, then we can actually get all these particular results and the images into this particular table using this particular library. So just a short way, like we have the add-ins which need to be added in this particular Microsoft Excel window, that is the MIDAS connector. Make sure that we already have the sign up our portal. So from there, actually it will connect your ID to our MIDAS server. Enter the API key to activate the MIDAS connector in the Microsoft Excel, and using the dynamic report image or table, take the necessary tables and images whichever you required for to input in the report, and then generate the report in Excel format. So either we can work with the query, that is by selection, sorry, by selection option, that is the images and tables taken from the dynamic report generator, or we can import by using the query. Okay, so make sure that this particular function should know how, what are the we can say the unit system, what are the force components you required. Accordingly we can update this into the report. So in summary, we have the key benefits of Excel VBA integrated with the MIDAS Civil Linux. So we can do the customization, automation, integration, and we can do the enhanced analysis as well. Okay. So we will try to make actually the short video how this particular Excel can be actually linked through the VBA. Because actually I think there is actually some syntax error I was getting, so that I will actually rectify. So we will actually share you the recorded sessions for the first one as well as for the second one together with all the sessions, and So if anybody is still actually having the doubts related to the activation and the trial version of the Civil NX, so please contact the Karthik Sharma. You can contact him through the email and you can get the these particular trial versions and as well as the recording of these particular sessions. Okay, so let me just take a few of the questions. Probably the video which I actually referred, I think you may actually get got an idea about how we can actually link the CivNX through the VBA for generation of the models as well as for the updation purpose. But still, I will actually try to create one video for generating this particular simple beam and do the optimization. Just actually some relevant questions I will take here and we'll discuss that one. Okay, regarding the substructure, here actually it's actually the basic session because we are actually thinking that all the attendees they are not actually full-fledged aware about the VBA. So that is why how to start with the basic idea about creating the node, say creating the section. Then once our complete beam is created, how we can actually do the analysis of that, getting the results in terms of stresses and do the optimization of that particular section for a limiting value of the stress. So for that purpose, actually we have scheduled this particular topic. But yes, we can do the this particular VBA integration for the substructure as well. So that can be done easily. Regarding the Autodesk Revit, yes, MIDAS Civil NX has actually the integration with the Civil NX. Like when you are actually installing the software, so like if you go to the C drive and the installation folder of this particular Civil NX, you will find the link for the Revit. So you can find this particular MIDAS link for the Revit structure, that is for the 2024, because the current version of MIDAS Civil NX is 2024. So that can be done here. Yeah. Yeah, so I will actually try for that particular VBA because here I think there is some problem with this particular. Yeah, let me just try once. I think I was not actually checking on that particular option. So one of actually the attendee has suggested me. I guess I have not actually checked on that one. So let me just try once. Otherwise, then we'll share you the separate video for this. Yeah. Okay. Probably actually in hurry actually I couldn't actually check on that particular option. That's why actually it was not generating. So in a just a quicker way, I just explain again this one. So we have actually the option for function for creating the function of creating the nodes. Okay. Next is so after creating this nodes, we are creating this section. So if you check our library, okay, I am first explaining with this particular library. Here. So if we go here and let's say for the cross section definition, parallelly if we check our section definition, properties, section properties, add, and here we are interested to define this particular solid rectangle section with some height and width. Okay, But here, as you can see in the tree menu, we have defined only the 11 nodes. So now we are defining this particular cross section. So I'll just run it, and we are actually expecting a rectangular section, solid beam with database second section. Okay. So now if you check this particular thing, okay, so we have the rectangular section generated. Okay, right. Maybe let's say we'll try for 0.3 and 0.1. Run it. Okay, for time being, I'll just keep it 0.1 and 0.3. Okay. Then, so our next function is regarding the so once we done generate this, now updating the section. So updating the section is nothing but now this is a little bit interesting. So here let's say we have the loop variable, okay, and we are specifying that this function will change its dimension. Okay. Okay. So we have actually this particular array for changing this particular width and depth, and further in this particular 14 to 11 we have the ID and the all. So for that we are actually iterating that particular dimensions, and using that one, now suppose I want to update this particular section. Let's say currently we have the section size of 0.1 by 0.3, but let's say I'll specify this particular variable to 2. So what happened, now this particular section, their dimension will change from 0.1 to 0.2. Okay, so we are specifying the variable of 2, loop variable of 2. Okay, then let's say the simpler way, I'll create the remaining part of the structure. So node and element, create create element. Let's say I'll specify the material. Suppose any concrete material with some grade of concrete, and just I'll create one beam. Then I just specify the boundary condition. Suppose this is the pin condition, and this side it is a roller. Okay, we'll apply some UDL over it. So we'll select the beam, we'll go to the load, static load, and let's say I'll apply one load of UDL. Okay. Now for this UDL, I'll go to the element beam load, and we'll apply the UDL of let's say 10 kilonewton per meter. Right. Now you no need to actually run the analysis here. Okay, so probably here we have the given command that run the analysis. So that run analysis command, once I perform the running analysis here, so that will perform the analysis in this particular software. Now I want to actually see the stress here. Okay, what is the stress coming at the bottom of this particular girder? So here I'll specify that particular function, and I want the bottom stress at that is at the CB4. So run it. So we are getting 60. Now if you check the results, so we can see the stresses, beam stress diagram, and here for the bottom, that is at the 4, if you check the values, okay, so we are getting that particular stresses here. Maybe at the at a particular element or location we are getting that particular stress. Okay, then fifth element basically. Now I want to do the optimization. So for optimization, so we have actually specified that okay, here there is a one stress value, and we have given the depth of 0.1. Now let it at optimize till the stress of reach the 10 MPa maximum. Okay, so it will do the iteration for every 0.5 meter of interval, 0.05 of interval. So that iterations if you perform, now it will do the analysis in a multiple time, and for every iteration it will show okay, for each and every iteration it will show what is your stresses. And then it will stop that particular analysis once we arrive at the stress below 10 Newton per mm square. So it will start reducing the stress. So 13.4, 38.4, 26.667, 19.592, 15 MPa, 11.852, and maybe one more iteration, so 9.6. So for 9.5, sorry, for 9.6 MPa of stress, the software has optimized this particular section to a depth of 0.5 meter. So that is how this particular optimization uh, can be actually done using our VBA integration. Okay, I think thank you. Those actually suggested me to actually check with this. Mr. Abhihai, thank you for this one. Okay. Currently, actually, the this particular yeah, I think in Microsoft Word we can actually check with the add-in, because still actually we are using with the Excel only, because this is actually the requirement from the user. So that is got actually added, but it's actually at the end it's a add-in only. So we can try in the Microsoft Office as well. This is regarding the whether the section optimization is possible for the non-composite PSC box. Yes, if any section is like value type of section, so we can actually refer to our library, the JSON library, and in that we can check what is actually the parameters specified for the user defined section. So there actually we can because user defined means make sure that we cannot actually control your area or the moment of inertia. We can actually control the sizes, but yes, it is as per again the users. We can actually try for that as well. So that's from my side. I hope. Yeah, so this session was actually helpful. So in our next session, we will be discussing about the two API functionalities, that is integration of Python and integration of Grasshopper into the software. So yes, so then see you on the Monday for our next session. So thank you for your time and have a nice day.